welcome to Chemical Wisdom. So today we are going to be dealing on the second part of this series on chemical bonding. So we are going to be dealing on electrovalent bonding, the bond between metals and non-metals. So in the previous video we said that metals are electropositive, in that they have a higher tendency of giving off electrons than receiving electrons. So how does electrovalent bond form? The metal atom transfers its valence electrons to a non-metal atom. By so doing, the non-metal becomes stable and the metal becomes stable. So the main purpose of bonding is to form an atom that has a completely filled valence shell. We are going to be looking at it in the examples below. The first example of electrovalent bonding is the bond in sodium chloride. So if you look at this bond now, it has a sodium atom and a chlorine atom coming in together to form sodium chloride. If you look at it well, this is the structure of a sodium atom and a chlorine atom. So what happens is that the sodium has only one valence electron, while the chlorine has 7. We have 1, 2, 3, 4, 5, 6, 7. The chlorine has 7 and the sodium has 1. So because the sodium is electropositive, like we discussed in the previous video, it will send out this single valence electron to the chlorine atom. What does that mean? The chlorine now has 8 valence electrons. It now has a stable shell, a stable electronic configuration. Look at this now as 1, 2, 3, 4, 5, 6, 7, 8. This is what the new chlorine atom, known as the chlorine ion, looks like. This is the sodium and this is the chlorine. So the sodium, on losing that single valence electron, that previous valence shell, there was another shell, there were 3 shells. If we look at it, this one has 1, 2, 3 shells. And the new sodium, has only 1 and 2 shells. In that, when it loses this valence electron, this valence shell ceases to be the valence shell. The second shell now becomes the valence shell. That's what's going on here. The second shell is now the valence shell. And the second shell has 8 electrons already. 1, 2, 3, 4, 5, 6, 7, 8. What does that mean? The sodium is now stable. The sodium is now balanced. It's now called a sodium ion. Okay, if you look at the chlorine too becomes 1, 2, 3, 4, 5, 6, 7, 8. This additional electron is the one that is got from the sodium. So the sharing and accepting of electrons is basically to form another structure that has a completely filled valence shell. Yes, that's what's going on. So let me show you another example. Another example of electrovalent bond is the bond in magnesium chloride. So if you look at this, we have a magnesium atom and a chlorine atom coming together to form magnesium chloride. So this is a magnesium structure, the atomic structure of magnesium, and the atomic structure of chlorine. So magnesium has 2 valence electrons. This is the valence shell now. It has 1 and 2. And the chlorine has 1, 2, 3, 4, 5, 6, 7. It has 7 valence electrons. So the chlorine needs only 1 valence electron. It's electronegative to accept electrons. It needs only 1 valence electron to complete the outermost shell. And, the magnesium cannot transfer the 2 valence electrons to a single chlorine atom. That's why a second chlorine atom comes into play. Then the first valence electron from the magnesium gets transferred to the first chlorine atom, and the second valence electron gets transferred to the second chlorine atom. What does that mean? The first chlorine atom now has 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons in the valence shell. The same thing to the second chlorine atom. It will have 1, 2, 3, 4, 5, 6, 7, 8. So both of them will have 8, 8. This is what the structures now look like. If you look at the magnesium ion now, it has 2 shells. Meanwhile, the previous atom of magnesium had 3 shells. In that, when it gives out this 2 valence electron, this outermost shell, this third shell, ceases to be its valence shell. The second shell now becomes the valence shell, and it has 8 electrons now. 1, 2, 3, 4, 5, 6, 7, 8. That means the second shell is balanced. That's what happens here. The second shell becomes the valence shell of the magnesium ion. So it has 1, 2, 3, 4, 5, 6, 7, 8 is balanced. But the chlorine The chlorine, the atomos shell is still the atomos shell, in that it just receives one electron and that balances it. So it has 1, 2, 3, 4, 5, 6, 7, 8. And the second chlorine atom has 1, 2, 3, 4, 5, 6, 7, 8. So these are non-metals form stability by accepting electrons, and metals form stability by giving off electrons. So when once they give off their valence electrons, the previous valence shell ceases to be the valence shell. The second shell, the shell under the previous valence shell, now becomes the valence shell of the ion. As you can see here, the ion has only 2 shells, while the metal structure, the neutral atom, had 3 shells. So when it loses this one shell, the next shell underneath it becomes the valence shell. So, and then it forms a positive magnesium ion. So this is basically what happens. In a neutral atom, there are equal number of protons and electrons. That's from the atomic number. The protons are the positive charges in the nucleus of the atom, and the electrons are the negative charges orbiting the atom. So because they are equal, that's why the atom is neutral. But in the case of forming bonding, in the case of forming ions, the magnesium loses 2 valence electrons. It loses 2 valence electrons. What does that mean? Number of electrons becomes 12 minus 2 to give 10 negative electrons, because it loses 2 in the process of bond formation. That's why it now becomes 10. If you look at it, the 12 positive protons now outweighs the 10 negative electrons. That's why the magnesium carries a charge of +2, because 12 minus 10 gives a +2 sign. That's why magnesium neutral atom forms a magnesium ion with a +2. The same thing happens to the chlorine. If you look at the chlorine, in the neutral atom, it has 17 protons in the nucleus and 17 electrons orbiting the nucleus. But in the process of forming ions, if you look at this structure now, from here, it has, if you count the total number of electrons, here is 17. Okay, maybe let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There are 17 electrons here and 17 protons in the nucleus. But in the process of forming ions, electrovalent bonding, what happens is that it gains an additional electron. This becomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are now 18 electrons. That's why we have a +1 electron added to the 17 electrons. That means 17 positive protons in the nucleus is outweighed by 18 negative electrons. That's why we have 17 minus 18 giving -1. That -1 is the charge on the chlorine ion. That's why a chlorine neutral atom will form a chloride ion carrying a charge of -1. Yes, so that's basically how electrovalent bonding occurs. Metals transferring electrons to non-metals, and that gives them a stable electronic configuration. So this is just the second part of this series on chemical bonding. So please make sure to follow up on the subsequent videos. And if you like this video, please hit the like button, and don't forget to subscribe and click on the bell icon so as to get notifications when we release new videos. And try drawing the structure of aluminum chloride and magnesium oxide. So you can, when you draw the structure, post it to this email. The email is going to be in the description below. The chemicalwisdom21@gmail.com. Just send in your structures. I'll look at it. If it needs correction, I'll correct and send it back. Please watch out for the next video on covalent bonding.